Hello everyone, hope you're doing and welcome back to my channel. Today we're at day 16 for the March Daily LeetCode Challenge. We have completed almost about half of the month. So if you have been consistent till this point, then a big congratulations to you. And again, if you try to do today's question, it's again based on the topic of binary search. Okay. So the same thing we are doing again. It's again on the topic of binary search. So my request to you will be, see, from the last 5 to 6 days, we have been getting questions on the topic of binary search. My request to you will be, please do go and see that, like, how this question are being solved. See, in this question, if you read, you will not get any hint that there is going to be a binary search question. Okay, but still this can be efficiently solved using binary search. So that is the beauty of binary search. If you see, if you even go for the topics, there are multiple ways to solve this question, even using the other columns, right? The heap and other columns also you can solve this question, but still binary search still remains a very important part for this kind of questions because it reduces the complexity by so much. You will see how that works. I will show you that. But remember, here we are actually going for the next level approach. Okay, it is actually from the bottom up approach. From bottom we are going to the top. I will show you how that works. But see, the instead of approaching the question directly, we are approaching the question from the point of the answer. Okay, I will show you why it is so. And let us quickly begin today's question. My request to you will be, please do read the question once. See, this thing I have determined that I will be promoting this point now, that I want you to read the question instead of me explaining everything. I want you to read the question. Please make it a habit that you read the question and try to understand the points, because in the interview also and even in the online assessment rounds, you will be alone. Okay, and there will not be anyone who will be explaining you through a video lecture like this. Okay, so my request to you will be, see, always, for looking for ideas, for looking for the logic building part, you can come and watch the videos, but your primary goal should be to understand the question on your own. Okay, to at least give it an attempt. If not, at least understand the question first and then come and see the videos. That is the minimum thing that I'm expecting from you. From last few days onwards, I've determined that I will not waste much of my time explaining the question, because see, it is not possible for me to read every word and then explain every part of it, because there are so many hidden aspects of every question. Okay, that you will get to know only when you trace the examples and only when you see the constraints. Okay, so I want you to do that part. Okay, I will only be highlighting some of the edge parts that you should be focusing on, okay, for this kind of questions. So coming to today's question, what we are given is, see, these are the ranks. I am assuming that you have read the question and then you are continuing from this point. Okay, so these are the ranks. Ranks basically means that, see, rank, the lower the rank, the more efficient the worker is. Okay, for example, if you talk about the rank 1 worker, that means this worker will be able to uh, repair cars the fastest. Okay, the worker which has the smallest rank will be able to repair the car the fastest. Okay, so always, like, because rank 1, rank 2, rank 3, so rank 1 is always the best. Similarly here also, the rank 1 will be able to repair the cars the fastest. And there is a formula also they have given, it is this one. Okay, r into n square. Okay, n is going to be the number of cars. Okay, so if you give n number of cars to this particular worker, okay, then it will take n square time. Okay, because r is 1 here. Okay, r is basically the rank are these values. Okay, now, so similarly, for, let us say, let's take example of this. Let us say this is the worker. Okay, and I am giving it 2 cars. So can you quickly tell me how much time it will take? So it will take 3 into n square time, since n is equal to 2. So 3 into 2 square, which is 3 into 4. Okay, you can calculate that, what is that number. So this is how it is being done. Okay, now the question is, they are saying return the minimum time taken to repair the cars. The catch here is, see, there are multiple workers present. What, this many cars are in the garage. Okay, so you can allot one car, or like any number of cars, by the way, to any of these workers. How many cars you have to allot, that is something that you have to decide. But you can allot any number of cars to any number of the workers, and then you have to say what is the minimum number of time it will take to repair the cars. Remember, all these workers will be working parallelly. Okay, they will be working parallelly. Remember that part. One more important part is that, remember, it is n square. It is not n. That means it is not like, see, once a worker completes a car, I will give it the next car. In that way, you will not be able to compute the the time correctly, because see, when you give 2 cars to a worker, it will, let us say r is equal to 1. Okay, let us talk about this particular worker. Okay, here r is 1. Okay, so for two cars it will take 2 square time, which is 4. But if you give 1 car and then another car, you will say that, okay, it is 1 square plus 1 square, which is 2. No, it is not the case. You will have to give them all the cars at once. Okay, that is, you have to first decide how many cars should be given to each of the workers, and only then you should use this formula to calculate. Okay, otherwise you will get wrong numbers, because remember, it is not a linear one, it is n square one. Okay, n square will differ. Okay, it is not like I am adding n plus 1 and getting 2, and it's not like that. Okay, it is n square, remember that. Okay, so basically, if you give 2, it will be coming as 4. It will 4 times the one. It will, see, 2 square means it will 4 times the one. It, see, the idea here is, if you, for example, let's say this. Okay, for this particular work, if you are giving 2 cars, okay, it will take 4 times the time it takes to repair 1 car. Okay, remember, it is 4:1, not 2:1 after that. Okay, that is how it will work. And similarly, for 3 cars, it will be 9:1 after that. Okay, remember that part, because it is being squared. Remember that. So that is how it is being done. Now let us see how to solve it using the binary search approach. Before that, I will show you one calculation. See, just this is the formula, right? See, these many for repairing n cars, this much minutes are going to be taken for each of the workers. Okay, now let us say I am talking about this particular worker. Okay, for this example I have done this calculation, so I'm talking about this particular worker whose rank is 4. Okay, whose rank is 4. Okay, that is R value is 4. Now let us say I want to know how many car this particular worker can repair in. Okay, yeah, how many cars this particular worker can repair in 16 minutes. Okay, I'm giving a very typical scenario, I'm giving you everything, I just need to know how many cars it can repair in 16 minutes. Okay, so let me zoom in. So this is the going to calculation, r into n square is equal to 16. Okay, because I know that I have 16 minutes, I know the rank of this particular worker, which is 4, so r is equal to 4 in this case. Okay, r is the one here, it is going to be 4. I just need to know how many cars this worker can repair. Okay, so r into n square is equal to 16. If you substitute r is equal to 4, then you will get n square is equal to 4. Then if you even solve this, you will get n equal to 2. Okay, so basically this worker can solve up to 2 cars in 16 minutes. Okay, that is how we are going to get it. So similarly what we are going to do is, see, here there are two limits. Okay, see, the first is L equal 1. Okay, because obviously, since see the constraint here, there will definitely be one car. Okay, there will definitely be one car. That means at least 1 minute will be required. Okay, right? It is not possible. See, idea here is, if there is only one car and let us say there are 100 workers, still only one worker can work on that car. Remember that. Okay, it's not like all the workers will come and work on single car and they will solve it in they will repair it in some milliseconds. That is not going to be the case. Even if there is one car, still there are 100 workers. Still, only one of the worker will work on that car. Remember that. Okay, so always the L is going to be 1. Okay, in this case, remember I'm talking about the left and the right ranges for the binary search. Okay, this part that I'm going to show now is the binary search part. Okay, so here L is going to be always 1. Now coming to R is going to be the maximum time that it can take. See, since I'm going to talk about the maximum time, I will always try to see how best I can solve it. See, always I will go for the most efficient worker. In this case, the rank 1. Okay, so I will take the min rank. Okay, among all the ranks, I'm going to take the min rank, because I will want to calculate if this single worker, if the best worker I have is going to work on all the cars that I have, then how much time it will take. Okay, so in this case, it is going to be R into n square, where R is equal to going to be 1. Okay, because the best worker has a rank of 1, so it is going to be 1 into n square. Okay, and this case is 10, so it is going to be 1 into 10 square, which is 100. Okay, so in this case, the R will be 100. So my range is between 1 and 100. Okay, in this case. Basically, I'm declaring answer and this loop starts. See, while L is less than equal to R, what I'm doing, first of all, I'm calculating the mid. Okay, how this mid is calculated, I will not repeat from the last 6 days, I'm repeating the same. This is a very typical way we calculate a mid in a binary search. Okay, this very typical way. I'm adding R minus L divided by 2 to L. Okay, simple as that. To get the next mid. Okay, it is basically L plus the half of it. Okay, simple as that. That this is the mid. Now I'm going to see this mid is going to represent the time. Remember that it's all about time. Even L and R are time, by the way. Similarly, mid is also going to represent the time. So I'm going to check whether in this many minutes can I repair this many cars or not. Okay, this is what this function will do. Remember, this is a function call in which I am passing the mid. Okay, I'm passing the mid to this particular function call. The function name is get max cars that can be repaired. Okay, in this much time. So this function will return whether I can repair these many cars in this many minutes or not. Okay, it will repair a boolean value, true or false. If it can repair all the 10 cars in this many minutes, then it will repair a true value, otherwise it will repair a false value. If the true value is repaired, let us see what we are doing. So if the true value is repaired, I am doing this part. So that means we have see, I am reaching a minute where I can repair all the cars. Okay, so definitely it is could be a possible answer, but remember, it is not the most efficient answer, because we have to return the minimum. Okay, remember that. It could be possible answer, but still it is possible that we can reduce the time further. Okay, so for the reason I'm putting it in the answer, but remember, this is just a possible answer. That could be in many more possible answers which are even less than that. Okay, so what we'll do, we'll reduce our search space. R is equal to mid minus 1. So the higher limit of my search is being reduced now. Okay, so this will now be mid minus 1. I'm just printing this for your sake. Always comment this kind of statements when you're submitting the code finally. Okay, then let us say this is false. That means this many minutes are not enough to repair this many cars. Okay, so we have to extend our minutes now. Okay, so what I'm doing L is equal to mid plus 1. So basically I'm trying to make the mid even larger. How to do that? I'm even the start itself I'm increasing further. Okay, L is equal to mid plus 1. So I'm reducing my search space, but in a way that the mid is going to increase now. Okay, as simple as that. So this will continue till L is less than equal to R. Okay, and this will keep continuing. So if you see the output of this is how the output will be. So one, the first answer that we'll get is C. First of all, I mentioned you for the example number 1, the search space between 1 and 100. Okay, because if you all out all the 10 cars to the best worker, it will take 100 minutes, and the starting point is 1. Okay, 1 minute. So between 1 and 100 minutes, the first possible answer coming is 50, then 25, then 18, and then 16. So 16 is the smallest possible answer that we are getting. So we are returning that as the final answer. Now, if you come to this particular function, what this function does, it's very simple. The way that I've showed you, the same thing that I will be doing. See, this is the function. See, what we are doing is, I'm declaring variable called repairs equal to 0. Then I'm going through each of the ranks. Okay, then that means I'm going through each of the ranks. I'm trying to see in these many minutes. See, in these many minutes, how like, each of the worker can repair how many cars. I will again repeat, in these many minutes, each of the workers can repair how many cars obviously in an isolated way, in a parallel way. Okay, see, I'm going through each of the ranks, then I'm calculating this formula. What is this formula? See, it's exactly like this. See, I'm doing the exactly reverse of this. I'm just trying to calculate what is the value of n. Okay, how to do that? See, first of all, whatever is the minute, that should be divided by r, and then you have to take the square root of it. Okay, so I'm doing the same thing. I'm doing, see, minutes divided by I. Okay, I is the, okay, I is the rank, by the way. I is the rank. So minutes, this is coming from here. Minutes divided by I, and then this value I'm taking a square root. Okay. To take a square root, what you have to do? You have to raise it to the power of 0.5. Okay. In Python, this double star means raised to the power. Okay. And if you want a square root, it has to be 0.5. Okay. As simple as that. So this particular value raised to the power 0.5, which means the square root of this value. Okay. And since, remember, this could be a fractional value, like this could be, it need not be whole number value, right? So I'm taking the floor of it to be in a safe way. See, I need not take the ceiling. Why I am saying this? See, the idea here is ceiling means you are going to the next nearest, to the next biggest, whole number. Okay, but I don't want to know that kind of approximation, because here, if you are not able to repair a full car, then you should not even consider that car, right? As simple as that. So for the safer side, I'm taking the floor of it. Okay, as simple as that. So I'm just adding that value to the car repaired at last. Okay, that is after each iteration I'm checking if card repaired is greater than equal to the total number of cards. Okay, remember, the cars is the total number of cards. If the car repaired is greater than equal to the total number of cards, then return in true. Okay, otherwise, when this whole for loop completes, you have to return false. Okay, as simple as that. Okay, now see, same thing will happen for every minute. Okay, that is in my search phase, it will start from 1, it will go till 100 in the example number 1. Okay, in the example number 1, see how this is coming. When again, many people are having this doubt. See, it's very clear. I want my best worker. Okay, what is the best worker? Best worker is the one which has minimum rank. Okay, so in this case, if you talk about example number 1, the minimum rank is going to be 1. Okay, I want my best worker to repair all the cars. Okay, so that will be done in, okay, r into n square meter. R is going to be 1 in this case, so min rank into cars square. Okay, as simple as that. So cars are 10, so 10 square is 100, so 100 into 1 is 100, right? So my upper limit is 100, lower limit is 1. So my search phase will start like that. We are getting the mid, we are checking that mid, and then we are going on lowering it if the mid is possible. Okay, if the mid number of minutes are possible, that mid number of minutes are enough to solve, repair this much cars. If that is the case, we are reducing the search space. Otherwise, we are shifting the search space in such a way that the mid becomes larger. As simple as that. Okay, in this way we are reducing the mid, in this way we are enlarging the mid. Okay, as simple as that. But remember, after each iteration of the binary search, the search space will be getting reduced. Okay, but how it is getting reduced depends on which iteration it goes. Okay, that's which condition is true. If this condition is true, that means the mid, we are reducing the search in such a way that the next mid is going to be larger. Okay, in this case, sorry, it is going to be smaller. The space is reduced in such a way that the next mid is going to be smaller. In this case, the search space is reduced in such a way that the next mid is going to be larger. Okay, as simple as that. And finally, once this whole while loop is done, we are returning the latest answer that we have got through this. Okay, as simple as that. So yeah, fun, that was all for this particular video. And yeah, you can go through the solutions. This question again, I will repeat. If you have been solving the last 3-4 days question, this will look very easy to you. You just need to know the basic idea that okay, it can be solved like this also. Okay, and if you talk about the space and time complexity, see, it's going to be very very clear. See, my whole thing revolves around how much the binary search is going to take. We all know the binary search is going to take log n time, but what is the n value here? So in this case, the n value is going to be the number of the time taken, okay, to repair all the cars by the best time worker. Okay, let us say that value is m, so it will take log m time. Okay, and in each of the logging iterations, I'm calling this function which is going to take o of n time. Okay, so it will be around like this. Okay, let me add it. So it will be something like this. Okay, n into log m. Okay, where m is basically the time taken to repair all the cars by the best worker, and n is going to be the number of the number of mechanics. Okay, the number of ranks, or anyway you call it the number of mechanics, right? That is all. And if you talk about the space complexity, see, if I look for the space complexity, see, these are the only variables that I'm using. I'm not declaring anything as such. Okay, I'm not declaring anything as such. So this is going to be constant space complexity and this much time complexity. Okay, O of this much time complexity. Okay, n into log m, where n is the number of workers, that is the number of ranks, and similarly m is the the number of time it is going to, that is the amount of time it is going to take for the best worker to repair all the cars. Okay, that is m. Obviously, like, since this value, see, m value is again dependent on number of cars also, because see, this is the formula basically. Okay, this is the formula, this much time it is going to take. Okay, as simple as that. So yeah, friend, that was all for this particular video, and I hope you enjoyed it. This question, I will say, like, see, if you have been solving previous question, this would be really easy for you. Okay, but again, if this comes in interview, obviously it will take some time for you. At least you will have to like seek some hints to get to know that okay, this can solve using binary search also. So yeah, friend, that was all for this video, and if you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further and to make this kind of videos further. Okay, this was my 145th day, and let us see, there are many more days to come. I'm always doing that. See you tomorrow. Thanks a lot.